record on this computer, which I really would like to record on a different one, but we're already recording here. So we are recording. All right, so welcome to our Introduction to Networks. And what I want to do today, not that. What I want to do today is talk a lot about IP addressing and about IP subnetting. One of the things as we get into the modules here, and this has been a little bit slow. I've got some grading to do, obviously, folks. So I'll try my best to catch up on that. We're really at the correct point where we need to be in terms of trying to figure out our different sections, but we're right here getting close to these chapter module 11. So we're going to be talking about subnetting. We'll talk about, I'm really not even going to go into the curriculum, folks. I'm just going to, this is something I've done enough that I can pretty much do it with my eyes closed. But I want to ask, can you see my flat frog screen? Say that 10 times quick. Somebody let me know that you can see it.
I think so.
Okay. Here in just, I'm going to pull my meeting controls down to, I've got a PC below me. So I've got another PC down here, and then I'll pull Flat Frog back up. All right, so do you see this? Squigglies.
Roger.
All right, so what I want to do to begin with is let's just talk for a second about, and I know this is a little basic, but let's just talk a second about binary, just about the types of things that we deal with when we're trying to teach our students binary. Obviously, we're all familiar with the base 10 numbering system. So 10 to the 0, 10 to the 1, 10 to the 2. So basically, you've got the 1s, the 10s, and here are the 100s, correct? So really, when we have $9 or a 9 in base 10, we're really just talking about having 9 in the 1s position. If we have, let me make that a little bigger. Yeah, I can just do it like that. All right. If we have 19, what we really have is we have 110 plus 9 1s, which gives us 19. Now, does anybody know why we use a base 10 numbering system for the most part? Anybody have any idea?
Because we have 10 fingers.
That's exactly right. We got 10 fingers. You know, if we had 6, we'd probably have a base 6 numbering system. So we've been using these all along. So again, if we had 101, let me go back a little bit bigger here. I made that a little too small. But if we go to 101, that's really 1 in the 1s position, none in the 10s, and 1 in the 100s position. So you end up, when you look at this, it's 100 plus 0 plus 1, which equals 101 in base 10. So let's put a 10 up here so you kind of know it's a base 10. Now, obviously, computers are not that smart. Computers are stupid. Computers are the dumbest things on the planet, and that's one of the things. Normal computers, now we start getting into quantum computers, are still pretty dumb, but they are base 2, which means they are based upon a bit. And a bit is the smallest unit, and in a bit there's 2 values that can be either on or off, a 1 or a 0. So for us in the world that we're inhabiting, it's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7th. And each one of these has a value at that position. So 2 to the 0 is 1, 2 to the 1 is 2, and 4. Now what we got here? 8. Keep going. We got 16, 32, 64, and 128. And for us, especially when we start talking about IPv4, which are 32-bit addresses or 4 octets, we really don't have to worry about 8 bits. So if we look at an IP address, okay, now all this is going to be IPv4 right now, folks. I'm not talking about any IPv6 because IPv6 is 128-bit addresses using hexadecimal. But IPv4 is a 32-bit address or 32-bit addresses. And they are octet, 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 octet. So it's 8 bits, 8 bits, 8 bits, 8 bits. 8 times 4 is 32. So if I have an IP address of 10.0.0.1, what I've really got is I've got 4 different octets. I've got one octet that is 128, 64, 32, 16, 8, 4, 2, 1. I wish I had $1 for every 1 or 0 I've ever put on a board. 2, 3, 4, 3, 4, 1, 2, sorry about the noises this pin makes, but the pin that came with this thing, by the way, we're using a Dell, and if you need a good monitor, honestly, the Dell makes a big screen monitor, and it's really nice, but this is the pin, and it makes a whole lot of noise. I'm trying to turn the video on here. Hold on. There it went. Oh, I turned it back on. There it is. It makes a lot of noise, so not the greatest thing. I'll tell you what you can do, though. These screens will support using a Cisco Service Book pin. I just couldn't find mine. Mine wasn't here, so we'll go back over here. So 1, 2, 3, 4, 5, 6, 7, 8, and then let me get rid of this real quick. That's one thing I like about this leapfrog, and then 0, 0, 0, 0, 0, 0, 0, 1. So this is the binary for 10.0.0.1. Now, hopefully I didn't make a mistake when I put that on the board. I don't think I did. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it is 10.0.0.1. So it is 32 bits. This is how the computer sees it. This is exactly how it sees it. This is how the computer interacts with it. It's also going to be how computers determine what network they're on, and we'll talk about that later, and what network the destination IP addresses are on. Any questions about base 2, any questions about conversion from binary to decimal, decimal to binary, all that's in the curriculum, and I'm not really going to cover that because it's probably something you already know, and I mean I will cover it if any of you here need it, but it is something that's pretty common and pretty well known already. Any questions on that? Let me pull up, get my chat going here. So I can sit down here. All right, good, good. Okay, all right, so it looks like everybody's good. So what I want to do now is I'm going to do a couple scenarios here. So we got a router. That's the symbol for router. By the way, my handwriting is horrific. It was horrific before I was hit by a truck 4 years ago. It's even more horrific now. So if you can't understand anything, please type in the chat and I will try to translate it. But this is a router with a gigabit port. Let's say this is GI 00 right here, or 000. Now that we're using the 4000 series, I've got to start using the 000. So this is a gigabit port, and then here's another gigabit port. And let's just assume that we've got a switch here, and this is GI 001, and there's a switch down here. Now, looking at this, how many different networks do I need to support the diagram as drawn right here? And we say we have PCs down, so it'd be PCs down here, happy little PCs. Always have happy little PCs. So how many networks do I need to support this as it is drawn on the board right now? You either put
rather with 2 interfaces, most likely 2 networks.
It would be 2 networks, and also Corey said it too. So it's 2 networks. So every interface on a router needs to be a separate network. Okay, so there'd be 2 networks here. Now, imagine that I gave you this, or your ISP gave you this. Now, I go ahead and I will tell you, I know this cannot be given to anybody because it is a private IP address. An ISP could possibly, though, be natting at their edge, and that is an 8, not a whatever that is. That's supposed to be an 8. 192.168.12.0/24. What class of address is this?
This is Class C and default subnet mask 255.255.255.0.
Okay, which means that we have network, 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 host. So we have 8 host bits, and there are 24 network bits. All right, so this is one single network of how many hosts, by the way? What's the formula to figure out the number of hosts?
2 to the power of h minus 2, so it gives us 256 minus 2 should be 254.
254, correct. It'd be 2 to the 8, 256 minus 2 is 254 usable hosts. We got a problem though. I've got this network over here that I just drew for you, but your ISP or your network administrator or whoever, they only gave you a single network. So what are we going to do? What can we do to take this single network of 192 168.12.0/24 and make it fit this network diagram right here.
We can borrow from the host bits, we can subnet it.
Exactly. And that, folks, is the definition of subnetting. The definition of subnetting is borrowing host bits to increase, I'm sorry about this pink, but I'm left-handed, that's all I can do, to increase network bits. Now, here's the problem with doing this. The second you start borrowing, from our host bits right here, you start reducing the number of hosts on each network. So let's go ahead and borrow 1 bit. Let's just borrow /25. Now, when we do that, we're going to be going over into our 4th octet. What is the value at the, let's go ahead and do this. I'm just going to go 0, 0, 0, 0. So 1, 2, 3, 4, 5, 6, 7, 8. What is the value right here in this position we're going to borrow from? I call it our variable.
128.
It's 128. So what we're going to do is we're going to borrow 1 bit and we're going to split this network into 2 subnets. Well, we're going to subnet it into 2 subnets of equal size using the variable from where we borrowed. So now these are all /25s because we borrowed 1 bit. How many hosts are there per subnet?
128 minus 2, so 126.
126, correct. So we borrowed 1 bit. So we leave 7 host bits. 2 to the 7th is 126 minus 2 is, 128 minus 2 is 126. Now, here, I want to show you why this is true. You've always heard you can't use the first or the last IP address in each of your subnets. And you've probably just been told that. And you may have never been told why. Well, here's why. If you look, so this is 0, right? This is 192.168.12.0. This is 12.0 right here. One of the rules is that all the host bits in any address cannot be all zeros and they cannot be all ones. So for 192.168.12.0, these host bits here, all of these host bits are zeros. If I go to 127, that's 127. 1, 2, 3, 4, 5, 6, 7, 8. What's wrong with this one? This one cannot be used because all the host bits are ones. So in this subnet, the first address is what's called the subnet ID. It's where all the host bits are zeros. The last address in the subnet is called the broadcast ID for that subnet, and that's where all the host bits are ones. Another good example, let's take 128 and convert it to binary. 128 binary is 1, 2, 3, 4, 5, 6, 7, 8. You'll notice all the host bits are zeros. 255, 1, 2, oops, hold on. 255, 1, 2, 3, 4, 5, 6, 7, 8. You'll notice here now, all the host bits are ones. So you've always heard you can't use the first, you can't use the last. But you may not have known the reason was because the host bits were all zeros or all ones. Of course, maybe you did know that, but somebody watching this who's in the class may not know. But that's the reason you can't use the first and you can't use the last. Now, looking at these two networks, we could go back now to our diagram. And I could now apply 192.168.12.0/25 network to this side. So the first usable address over here would be .1/25. And then on this other side here, I could do 192.168.12.128/25. And then what's the first usable address I could actually put on this interface? Corey, anybody? 129. Exactly, Corey. So 129/25. So what we just did is we took our major network and we subnetted it into two separate networks. Now at this point, we have used standard subnetting. We have not used VLSM because both networks are using the same mask. So we just took and split it in half. Now, I want to tell you, and if you watch the videos I sent out last week, I actually did give you some steps to subnetting. So for instance, if I gave you the network 192.168.12.0/24 and said, I want 10 subnets. Okay. I got a couple rules. First off, rule 7 holy steps of subnetting. The first step is determine the number of subnets you need. Now that can be someone gives you the subnets and says you need 10 subnets. It can be you have a diagram. Where'd my diagram go? Here it is. You may have a diagram that you have to determine the number of subnets you need by looking at the router. Okay. Or again, you may just be told. In this case, you've been told. Step 2 is always write out the host bits. 1, 2, 3, 4, 5, 6, 7, 8. The reason I do this is so students will understand that you are borrowing these host bits. You're not just pulling numbers out of the air. You're coming up here and looking at how many host bits you have. You're then writing those host bits down here so that you are able to know that I am borrowing the host bits. Step 3 is determine the number of bits you must borrow to get the needed number of subnets. And there's a formula for it. 2 to the n equals number of subnets. And in this case, n equals the number of borrowed bits. So to get at least 10 hosts, or excuse me, 10 subnets, borrowed bits, not hosts, borrowed bits. I sidetracked myself. So to get the number of subnets, how many bits will I need to borrow to get at least 10 subnets? What power will I have to raise 2 to?
4 bits.
4 bits. What's 2 to the 4th?
16.
So you're going to end up with 16 subnets. Okay. Now, step 4 is always turn on the number of bits you borrow and find the value. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. So you take your host bits from step 2 and you write down the number of bits you borrow. And what's the value once you do that? I want to show you all a real quick trick, by the way. If it's a 1 and all zeros, it's 128. If it's 1, 1 and all zeros, it's 192. 1, 1, 1, all zeros, 224. 1, 1, 1, 1, it's 240. If it's 5 ones, 3 zeros, it's 248. 252, 254, and 255. So you can learn those breakpoints so that you know if you see this, 1, 2, 3, 4, 5, 6, 7, 8. What is that? What's the value there?
129. Well, actually 128 plus 2, so 130.
130. Because you know if it was the 1 and all zeros, it's 128. So it's 128 plus 2. So there's shortcuts you can learn and teach your students so they'll be able to do those conversions fairly quickly. So at step 4, the next thing you need to do at step 4 is take the existing mask and add to it the value you found in step 4. Actually, that is, believe it or not, that's actually step 5. That gives you your new subnet mask, which is 255, 255, 255, 240. Step 6 is you need to determine what I call the variable. And a lot of people call it different things. Some people call it the variable. Some people call it the magic number. I call it the variable, but it's the variable that your subnets are going to roll by. And you do that by looking up at step 4. So you come back to step 4, and you find the highest order bit, and that's from left to right turned on, and find the value right there. So we know it's 128, 64, 32, 16. So the variable is 16. Now, typically that will also match right here, but that's not always true because when we pass the bit boundary in a non-class C, you're going to have more than a single variable. You have multiple variables. It is at that point that you can then come over to step 7 and start writing out your subnets, because you know what you're going to roll the subnets by. This is the variable. You start with the major network number, 192.168.12.0. And by the way, I'm not going to rewrite 192.168.12 again because A, I'm lazy, B, it doesn't change. So in the fourth octet, it's .0 to .15, .16 to .31, .32 to 47. And if you'll notice, every single subnet is 16 places apart. Now, I'm not going to write all these out to the very end, although I can tell you the final one is 240 to 255, because the last subnet always ends with the mask, whatever the mask is in that particular octet. You'll notice too, 0 is a number in binary, so 0 to 15 is 16 spaces or 16 places. So what we just did is we took the major network 192.168.12.0, we subnetted it into 16 subnets, and each one of those subnets has 2 to the 4th host minus 2, so each subnet has 14 hosts on it. And that is because when we borrowed those 4 bits, we only left 4 host bits. And 2 to the 4 is 16 minus 2 is 14. So that is one of the reasons why I make sure my students understand this right here. As you make more networks, you decrease the number of hosts on those networks. So we went from a single network of 254 usable hosts. So if it's /24, we got 254 usable hosts. We've gone down now to 16 networks of 14 hosts. Now, I want to stop at this point and ask questions. Any questions on the 7 holy steps of subnetting? By the way, back when I was first learning how to subnet years and years and years and years and years ago, I come up with this after spending an entire night of going through I sat on the couch and just subnetted and subnetted and subnetted. It actually hit me in this, believe it or not, shower one morning. I probably didn't even know that, scary thought, but I just come up with this and said, the only thing that has changed over the years, I used to have this formula, 2 to the n minus 2, because we used to teach back in the old days that you could not use subnet 0, but that is no longer true. We also taught that you could not use the broadcast subnet. That too is not taught. In fact, it wasn't true at the time either. You could use subnet 0 and you could use the broadcast subnet, but nobody did it. Now we don't use that. We just use 2 to the n. Feel free to use these. Feel free to use any of my videos on subnetting. There's people out there that do it a lot better than me. I'm not a math major. This is what I had to come up with to do basic subnetting. Now, this is very important. This is classful subnetting. What is the mask? What is the / notation on all the mask or all the subnets that I have created here? You know it's /24, and then we borrowed 4 more bits. So all of these are /28. So every one of these are /28. So we haven't talked a bit about VLSM. Nothing. This is standard classical subnetting. And I'm going to tell you something. I firmly believe the curriculum does not do the students any favor because they do not teach this first. I know they talk a little bit about classical, but then immediately jump into VLSM. When you're teaching this to your students, teach them classical subnetting first. Then what you can do is you can go back to an example like we had before. So let's go back to our example. And I'm going to say, okay, now let's imagine, folks, that this diagram changes. Let's imagine that instead of what I've got here, okay, let's imagine that we're going to subnet this differently. We're going to subnet it to meet, here, just let me create it. I was doing it. It's easier just to draw another. We're going to create a new network, okay, like this. Okay, here's our switch. I'm not going to draw our happy little PCs this time. But we're going to draw, and we're going to do this. All right, so I'm going to give you the same network. So we got 192.168.12.0. .12.0/24. Step 1, how many subnets do we need? One here. We need one that's shared between these two, this point-to-point network here, and we need one here. So when we look at step one, we need 3 subnets. Okay. Step 2, let's write out our host bits. I'm just going to write them over here. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I know that hadn't really changed, but I'm going to go to step 3. I'm going to here. How many bits do I need to borrow? So what power to n do I need to get at least 3 subnets? N has to equal 2, right? Because 2 to the second power is 4. All right, so we got to borrow 2 bits. So step 4, turn on those 2 bits. Find the value, which is 192. We now know our new mask. Our new mask is 255.255.192. Okay. Step 5 is writing out that new mask. 192. Step 6, we need to find our variable. So we look up here and we go, okay, the highest order bit turned on is right here, and the value there is 64. So my variable equals 64. And now I'm going to be able to break up my network. So I'm going to go 192.168.12.0. This is step 7, by the way. We're going to find our subnets. .0 to .63. .64 to 127. Oops. Pretty bad handwriting there. Sorry about that. 127. .128 to .191. And .192 to 255. Okay. So now we can start pulling these networks out. The .0/26 network can go here, so this will be .1. The .64/26 network can go here. We can put .65 here and .66 here. And over here, we could put the .128 network /26, and we could put .129 on the actual interface at 129. All of these are /26s because we borrowed 2 bits. How many hosts are on each network?
62.
62, yeah.
62, okay, exactly. We got 6 host bits left. So 2 to the 6 minus 2 equals 62 usable hosts. And here's how you get the light bulbs to go on with your students, folks. This is a point-to-point network. How many hosts are there ever going to be on a point-to-point network? 2. That's the whole point-to-point part. So you are using a network of 62 usable host addresses. And I guess I should put addresses here, but that is implied addresses. But you're using 60 or only 2 of the 62. So you're wasting 60 addresses right here. That's a huge waste. Wouldn't it be neat if we could do something not to have to waste those addresses? Well, that's variable length subnet masking. That's the whole purpose for VLSM. So let's do this differently. Let's go in here and let's say what I want to do first is I'm going to just use what I've already got here. So I'm just going to pull out right here, this /26. I'm going to pull that one out and I'm going to make this .65 /26. That's a 64 network. Okay. But we're going to do something different right here. We're going to figure out a way that we can use some addresses in a better fashion. We're not going to waste all those addresses. What if we could go ahead and say, all right, we're going to pull this network out and use it, which we did right here. We're going to pull this network out and use it, which we did right here. But right here, instead of using this big network of 62 hosts, the .0/26, what we're going to do is we're going to take the network 192.168.12.0/26, okay? And we're going to subnet a subnet, which is really what VLSM is. So we borrowed the /26. If we borrow the /27, the variable at that point becomes 32. So we're going to take this and we're going to break it down to 0 to 31 and 32 to 63. Now what I want to go back here and show you is this. Wrong one. I'll go back here and show you is this. We're not pulling numbers out of the air. We took this subnet 0 to 63, which was /26. We then borrowed one more bit. And now we still have 0 to 63, but we've broken this one network, which was 0 to 63 /26. We borrowed one more bit and broke it into two smaller networks using one more the variable of 32 by borrowing one more bit. Now that's still way too many hosts, usable hosts per network, because it's 2 to the 5th, which is 16. Actually, it's 32 minus 2, which is 30. So there's still 30 hosts usable on these networks. So it's still way too many. So let's do this. Let's borrow another bit. Let's do /28. The variable becomes 16. Now we can leave this bottom one alone. Let's just break the top one apart. So we go 0 to 15, 16 to 31. Okay. Still too big because we've got 2 to the 4, which is 16 minus 2. So we've got, at this point, still too many host addresses on these subnets. So we'll borrow one more, /29, which the variable becomes 8, and we'll break this one down to 0 to 7 and 8 to 15. Still too big. We'll borrow one more bit, go to /30, which is going to make it just right. And our variable becomes 4, and this is 0 to 3 and 7, or excuse me, 4 to 7. And now we've got a network. So if I do network 192.168.12.0/30, that is this network right here. The first usable address is .1, the last usable address is .2, because 0 is the subnet ID and 3 is your broadcast ID. We could then come back over to here, and folks, we could use that 192.168.12.0/30 network, and we could put .1/30 here and .2/30 here. Just saved a bunch of addresses, because if we go back and look, we've still, at this point, we use this subnet, which means we can no longer use this one, and we can no longer use this one, and we can no longer use this one, because these numbers 0 to 3 are included in those subnets. So if you tried to go back and use any of those in that line, you would have overlapping addresses. But you'll notice this subnet's still available. We didn't use it. This one's still available. Okay. And if we wanted to break them on down, we could break them on down and even more. But that's still available. And in fact, this is still available. So there are portions available that we didn't use. So what it allows you to do, what VLSM allows you to do, variable length subnet mask, it allows you to better fit your subnetting to what is needed in your network. Now, I'm also going to tell you something that I don't agree with the curriculum on. The curriculum always has you pull your biggest subnet, however many hosts you need. It has them pull the biggest from this lowest range. That's what the curriculum always does. Folks, real world, I want all of my, I want .0, .4, .8, .12, .16, .20, .24, .28. I want those to be the addresses I use for all my point-to-point links. I don't want it to be .128. What would that be? 132. .136. .140. That's crazy. people use the low numbers typically in business. They use the low .0, 4, 8, 12, 16, etc. in order to be, or 8, 12, 14, 16, to be their point-to-points because it's easy to remember. Also, there's different ways of doing this. So as far as pulling out different networks. So if I ask you to use, if somebody had come out here and subnetted this one all the way down to /30 and used one of those for this link, that would have been fine. It would have worked. Now, I will tell you this. If you do that in the packet tracers, and that's probably where some of you are getting in trouble with the packet tracers that are subnetting packet tracers, if you don't do it exactly the way the packet tracer says, it will not give you credit. Now, it may work all day long, but it may not be exactly what they were looking for. So when you're doing the subnetting packet tracers, make sure you pay very close attention to exactly what it's asking and exactly what subnets it asks you to use. Otherwise, you won't get credit for things. Okay, I'm going to pause right here, and I want any questions that you may have. I want you to give me some questions here. Any questions at all on subnetting, on the 7 holy steps of subnetting? By the way, I did put that in the videos that I sent out to you. The 7 holy steps of subnetting are on my YouTube channel. And no, folks, I don't make any money on my YouTube channel. It's not even monetized, so don't think it is. But you search for KCaudle52, and also you ought to get these in your links. But KCaudle52 and my beautiful dog Wookie, who unfortunately is no longer with us. But if you just search in here and you search for the 7 holy steps, I actually think this video is so old that it has still 2 to the n, 2 to the n minus 2. I think that video is that long, but here it is, the 7 holy steps of subnetting. Yeah, that's 7 years ago. Look how skinny I was. It's kind of scary, isn't it? I will say that's one of the things that's hard to look at when you start looking at videos of yourself when you're that old. Yeah, Peter. You look at yourself and go, good gosh, you know what's funny? Hold on. I'll tell you something funny. I think, if I'm not mistaken, check this out. I got on the same shirt. Dang. 7 years later, I got the same shirt on. Yeah, that's hilarious. Yeah, 7 years ago, I was a whole lot skinnier and I would say better looking, but I wasn't any better looking. But the 7 holy steps, there is a video that you can go and look at under my YouTube channel, and it just goes through the 7 holy steps, and I'll walk you through. So see, actually no, it does just have 2 to the end. So this was a this is more in depth than what I just gave you as far as the steps. And I'd hope that you'd already looked at this before I was going over this. If you have not, again, go back to my KCaudle52 and just search for the 7 holy steps of subnetting. There's also a bunch of other lectures on here from previous classes. So if you ever get to a playlist, our playlist, by the way, is the spring classes, which is here. This is all of our stuff, all of our classes that we've been doing so far. But there's also some ASC ITC tutorials. If you're not with us as an ASC ITC, feel free to look at these because there's got some things in here about how you can add students to a NetLabs class. That's something I just did because we're helping a lot of people. And also looking at adding existing instructors to your academy, et cetera, all those things. So again, not trying to get to 100,000 YouTube users, although I would take it. But just want you to know that's available there, and there's some stuff in here. Feel free to use it, play with it, whatever. I'm still working on, actually I am working on getting, yeah, Corey, you're right. I've always said, Corey, that, and I've learned very quickly that the getting old is not for wimps. You don't make it to get old if you're a wimp. So that's for sure. But I will say that anything in here you want to use, feel free to use it with your classes. I am working on lectures for the new curriculums. So hopefully, and especially in light of everybody going online and the fact that I'm going to have time, we are allowed to come to our campus, by the way. We are. So we may come, I'll be in here recording some videos on the new stuff. So be aware I'll be doing the new modules. But you can see there's a bunch of stuff in here if you just want to go look at some and find something concerning a particular thing. There's a lot of stuff in here. There's even a couple videos on how to clean your bicycle if you ever want to know how to really clean a bicycle well. Yeah, that's from 2014, so 6 years ago. But yeah, there's all kind of stuff to show you crazy things on my YouTube channel. All right, any questions about the subnetting? Are we good? Do we feel okay with it? This is one of the single most important topics inside of Introduction to Networks, by far. And to be honest with you, we'll go next week. We're going to be doing more subnetting. We'll be doing more VLSM examples. We'll meet again. We'll talk more about them. I'm going to do individual. If anybody needs an individual session with me on subnetting, please let me know. I may have to run it from home, and if I do, my internet there is not the greatest. But be aware, I will try my best to help anybody in any way I can. All right, what I'm going to do then is I'm going to stop the recording. Yeah, it's all about practice. I will say if you don't use it, that's one of the things that's tough. So make sure you do go out there and just practice.